Florida International University is amping up the wow factor in their wall of wind. The state-of-the-art hurricane simulator is already capable of generating Category 5 wind speeds up to 157 miles per hour. But as we begin to see stronger hurricanes, Dorian was an example, wind speeds topping out 185 miles per hour, the system is in need of an upgrade. Well, the university was recently awarded a nearly $13 million grant that will allow them to build a brand new facility that will generate stronger wind speeds and even simulate storm surge as well. So here to tell us more about it is Associate Professor of Civil and Environmental Engineering at FIU, Dr. Ioannis Zisis. Dr. Zisis, thanks so much for joining us today. And I guess let's start out by telling us what you hope to learn by this new facility with these stronger wind potential.
Thank you for the opportunity. It is an exciting program. We try to simulate stronger winds, as you mentioned, but I think the most unique aspect is we try for the very first time to design a facility that will combine wind and coastal hazards. So the water component is included, or we hope that will be included in this facility.
Yeah, Doctor, I wanted to talk a little bit more about that angle because we've seen so many times that water does so much of the damage and causing the fatalities. So how will the facility work? I mean, how big of an area of water do you envision? And is this going to be a bigger wall of wind, the whole facility taking up a larger footprint than the one you currently have?
Yeah, that is correct. These are questions that we will be answering in the next 4 years. We have a multidisciplinary team, 9 different universities and an industry partner, and we'll try to design something, a facility that will achieve close to 200 miles per hour, so much stronger than the existing facility here at FIU, the wall of wind. But the most important thing is we want to have a water basin in front of the fans to recreate the storm surge and the water that comes with these type of events. The size is to be determined. These are like, again, the questions that we try to answer. We're going to go back and try to review field data that are available. We're going to use simulation tools, computational methods, and we're going to combine all different expertise that we have to come up with the requirements. How big this facility needs to be, how many fans, what would be the power of the fans, the water basin, as you said, what should be the size for such facility.
What would be the ultimate goal here when it comes to the water and the surge? I mean, could it be possible to build a waterproof home?
Waterproof home, the objective is to examine the effect of the combined hazards. So up to this day, we have facilities that can simulate individually those events. But we don't have the capability to experimentally check the effect of of wind and water. So the ultimate objective is to be able to test at full scale. As you said, a single family home will be placed on the test section, and we should be able to consider both very intense phenomena. And the ultimate goal, of course, is to design, if you want to call it the waterproof, that is a nice term, but yes, a home that is resilient to these hazards.
And Doctor, kind of a two-pronged question here. With the current wall of wind, did you guys learn anything through your experiments that then translated into different building codes? And then the second part, do you hope that you will continue to strengthen those types of results with this bigger facility?
Absolutely, absolutely. This is throughout the years, we have conducted different types of research, and I always try to, as I call it, have a codification section in my studies. So all the findings that we get from the wall of wind experiments, we put together proposals, we submit them to the committees that are responsible for those building codes and wind standards. And we ended up contributing to the well-known ASC 7 standard, wind standard from the American Society of Civil Engineers. and the work eventually reaches the consumer, the client, basically, and resulting in stronger homes.
Doctor, we just have a few seconds left, but very quickly, is it your hope that we can end hurricane damage being as bad as it is today based on the work you do in this facility?
That is an ongoing objective for all researchers and natural hazard engineering. That's what we're after, to make homes stronger, to understand the impact, and be able to design safe homes, ultimately the safe homes that every single consumer needs.
We will cheer on that goal along the way. Dr. Ioannis Zisis, thanks so much for joining us today and explaining this project.
Thank you for having me.
And still to come here on Weather Underground, was this past week